A very good morning, students. In today's class, I'll be talking about the topic limiting reagent. I'll be using the alphabets L and R for the representation of limiting reagent from now onwards. Any reactant of a chemical reaction that gets finished during the reaction is the limiting reagent. Now, to understand it a little better, let me take an example. For a reaction where magnesium reacts with sulfur to form magnesium sulfide. Before I give any information for the reaction, the first step for all numericals where you've got a chemical reaction involved, you need to balance the reactions. Luckily for us, this particular reaction does not need any balancing. 1 magnesium combines with 1 sulfur to give you 1 MgS, which actually means 1 mole. 1 mole and 1 mole. Hence, 1 mole of magnesium requires 1 mole of sulfur to form 1 mole of magnesium sulfide. The other way of representing it would be 1 mole of magnesium is equal to 24 grams. 1 mole of sulfur is equal to 32 grams. And 1 mole of MgS is 56 grams, the product. So, when 24 grams of magnesium combines with 32 grams of sulfur, you would always get 56 grams of magnesium sulfide. Other than this, the equation also gives us the information that Na, what does Na stand for? Avogadro's number. That is 6.022 into 10 to the power 23. These many magnesium atoms will combine with same number of sulfur atoms and you will end up in the same number of molecules of magnesium sulfide. To get the concept a little better, I'll be taking an example. You have to identify limiting reagent for the above reaction if 120 grams magnesium reacts with 200 grams of sulfur. If 120 grams of magnesium combines with 200 grams of sulfur is the question given to you. Working it up, we very well know that you will be requiring 24 grams of magnesium and it would combine with 32 grams of sulfur. So you need to know the ratio of combinations. Working on the same principle, we know that if 24 grams magnesium needs 32 grams of sulfur, that is available from this information. Hence, if I have just 1 gram of magnesium, it will require 32 divided by 24 grams of sulfur. Since I have available 120 grams of magnesium, hence for this 120 grams of magnesium, I would be requiring this much amount of sulfur. On calculation, this value comes out to be 160 grams. So your requirement of sulfur for this particular amount of magnesium is 160 grams. Hence, from the question we know 120 grams of magnesium will completely react with 160 grams of sulfur. Do we have this much sulfur? Yes, we do. We have got 200 grams of sulfur, but our requirement is only 160. Hence, out of the two, we can very well see magnesium is getting finished. Hence, this becomes your LR. The reactant which gets finished. जो खत्म हुआ वो limiting reagent हुआ, which limits your reaction. We call it a limiting reagent only because it will be the reason to stop the reaction. It limits it. Similarly, in the other case, you can also for this question find out the amount of the reactant which is in excess. In this question, your limiting reagent becomes magnesium. Therefore, your excess reagent becomes sulfur. How much of sulfur do you have in excess? The left amount of sulfur is equal to 200 grams was your given amount. Reacted amount is 160. So you're left with 40 grams of sulfur is unreacted. Lastly, we can also calculate the amount of magnesium sulfide. On the basis of law of conservation of mass, the total amount of reactants reacting will give you the total amount of products. Since in this case, you have got only one only one product formation, that is MgS. So the amount of MgS formed would be equivalent to the reactions where magnesium and sulfur are combining in the amounts. You have 120 grams magnesium, out of which total amount is reacted, plus it reacts with 160 grams of sulfur. So your amount of magnesium sulfide would work out to be 280 grams of MgS is formed. I'll take another example to drill the concept a little better. The second example that I'm going to take has, you again need to identify the limiting reagent and the amount of magnesium sulfide formed if 2 grams each of magnesium and sulfur undergo a reaction. We very well know 24 grams magnesium needs 32 grams of sulfur. Therefore, since we have got 2 grams of magnesium, therefore 2 grams magnesium will require 32 divided by 24 into 2 grams of sulfur, which comes out to be 8 by 3, which comes out to be 2.66 grams of sulfur. Now re-refer to the question. For 2 grams of magnesium, the required amount of sulfur is 2.66. Do we have that much sulfur? No. The amount of sulfur that you have is only 2 grams, which means total amount of magnesium is not going to react, since the amount of sulfur is not the available amount, is only 2 grams and your requirement is 2.66, which means magnesium will never completely undergo the reaction. Hence, magnesium cannot be your limiting reagent, which leads to the conclusion that sulfur is your limiting reagent. Now, working it the other way, 32 grams of sulfur needs 24 grams of magnesium. So, 2 grams of sulfur will need 24 divided by 32 grams of magnesium multiplied by 2, you end up in 1.5 grams of magnesium. Let us recheck it up. 2 grams of sulfur was in your question, needs 1.5 grams of magnesium, which you have. Hence, this would get finished as already done. This therefore again proves that this is your LR. Magnesium therefore becomes your excess reagent. How much is the excess of magnesium? To get that value, how much did you start off with? 2 grams. How much is being used up? 1.5 grams. What are you left with? 0.5 grams of Mg is left in excess. Lastly, to calculate the amount of magnesium sulfide formed. Again, since it is a reaction where magnesium combines with sulfur to give you MgS, on the basis of law of conservation of mass, the amount of magnesium that has reacted is 1.5 grams. Amount of sulfur that has reacted is 2 grams. Since it is the limiting reagent, it reacts completely. Hence, you have to end up in 3.5 grams of magnesium sulfide. Please refer to my next class of limiting reagent for more examples. Thank you. With this, I end my class.